Okay guys, I welcome you all to Engineers Academy. Do subscribe my channel if you haven't done it yet. Now we are going to solve this problem from chapter 14, Hibbeler Dynamics. And the problem says that the 2-pound collar has a speed of 5 feet per second at A. So the velocity at A is 5 feet per second. And the attached spring has an unstretched length of 2 feet. So let me write that the velocity at A is 5 feet per second and the unstretched length is 2 feet, and a stiffness of the spring has a stiffness of 10 pound per feet, and it is said that if the collar moves over the smooth rod, determine its speed when it reaches point B. So we have to find the velocity at B. And the normal force of the rod on the collar, so we have to find the normal force at B and the rate of decrease in its speed. So we have to find the tangential acceleration. The rate of decrease in the speed is the tangential acceleration. So we have to find that tangential acceleration. Now to find the velocity at B, we have to apply the law of conservation of energy between point A and B, which says that the kinetic energy at point A plus the potential energies at point A, that will be equal to the kinetic energy at point B plus the potential energies at point B. So at A, and the velocity is 5 feet per second, so the kinetic energy at A is 1 divided by 2 mass. So mass is the weight divided by G value, which is 32.2 times VA square. VA is 5, so that is 5 square. And we have two kinds of potential energy. One is the gravitational potential energy and the other one is the elastic potential energy, since we have the spring. So at A we will have the gravitational potential energy at A plus the elastic potential energy at A, and similarly at B we need to find the velocity at B, so that will be 1 divided by 2. Again we will have the kinetic energy 1 divided by 2 times mass. So mass is again 2 divided by G value 32.2 into VB square plus the gravitational potential energy at B plus the elastic potential energy at B. So now the gravitational potential energy at A, that is always equal to the weight times h, but we have to define our datum line. So the x-axis is our datum line. This is our datum line for the gravitational potential energy. So when the collar is at A, the height from the datum line is 4.5 feet. So that will be equal to weight. So weight is 2 pounds. So 2 into 4.5. This is 2 into so that is 9 pound feet. Similarly, the elastic, when the collar is at A, the elastic potential energy will be equal to 1 divided by 2, and K value, K is 10, and the stretchness in the spring at A, when the collar is at A, so we have to find the stretchness in the spring. So that is, let's say, SA. So that is SA square. Now SA is, we can say that SA will be equal to the stretch length. Let's say that this is point O, so the stretch length is OA minus the unstretched length. So OA is 4.5 minus the unstretched length is 2, that is 4.5 minus 2. So SA is 4.5 minus 2. So I will write 4.5 minus 2 square. So 4.5 minus 2 is 2.5. So this is 2.5 square. So this is 10 divided by 2 is 5. So 5 into 5 multiplied by 2.5 square. This gives us 31.25. So 31.25 pound feet. So this is the elastic potential energy at A. Now the gravitational potential energy at B will be 0, since the collar will be at datum. So the height from the datum is 0. So the gravitational potential energy at B is equal to 0, and the elastic potential energy at B will be equal to 1 divided by 2 K as B square. Let's say that the stretchness in the spring when the color is at B is, let's say, SB. So we can write that this is 1 divided by 2, K is again 10, and SB will be this OB length. OB will be the stretched length minus the unstretched length. So OB will be 3 feet minus 2. So 3 minus 2, so that is 1. So that is 1 square. So this will give us 5 pound-feet. So now we can plug in all those values. This 2 will cancel out, this 2 will cancel out. So this will be 5 square. So that is 25 divided by 32.2 plus the gravitational potential energy at A. So this is 9 plus the elastic potential energy is 31.25 at A. This 2 will cancel out. So this is VB square divided by 32.2 plus the gravitational potential energy at B is 0 and plus that elastic potential energy at B, which is 5. So now let me calculate this. This is 25 divided by 32.2 plus 9 plus 31.25, and if I bring this 5 to the other side of equation, so it will become negative. So we will have minus 5 equals to this. So we will be left with this equation. So now minus 5, this gives us 36.03. So we can say that VB square divided by 32.2 is equal to 36.03, and we can say that VB square is 36.03 into 32.2, and if we take the square root, that will give us the velocity of the collar when it is at point B. So this is, you can say that answer, which is 36.03 multiplied by 32.2, this gives us the velocity equals to 34.06. So VB is 34.06 feet per second. Now to find the normal force and the decrease in the collar speed, we have to consider the normal and tangential coordinates. So for that we have to find the tangent axis, the tangent axis angle with the horizontal. So the tangent to the trajectory at point B is this line, right? Let's say that this orange line is tangent to this trajectory at point B. So first of all, we have to find this angle with the horizontal. So this angle with the horizontal can be determined by taking the derivative of this y of x function. The trajectory of this collar along this rod is given as y as a function of x. So we are given this. So we have to find dy by dx. So now dy by dx, that will be equal to, if we take the derivative of this, so that the derivative of 4.5, which is constant, is 0, and the derivative of this will be minus 1 divided by 2, and x square derivative is 2x. So this will cancel out. So we are left with minus x. So the derivative of this function is minus x. And as we know that if I draw a triangle, if I make this line, so we have this triangle and this angle is theta. So this perpendicular is dy and this is small change in x. So if we apply tan theta to this triangle, so tan theta is dy by dx. So from this we can conclude that dy by dx, the derivative of this function with respect to x, is tan theta. So tan theta equals to minus x. That is the first derivative. So we want to find the angle of the tangent with the horizontal at point B. So at point B, the x is equal to 3 feet. So from the origin, the point B is at a distance of 3 feet in the horizontal direction. So we can say that tan theta is minus 3 when x is equal to 3. So from this we can find the angle of the tangent line, that is theta equals to tan inverse of minus 3. So tan inverse of minus 3 is tan inverse, that is shift tan inverse of -3. This gives us -71.56. So that is -71.57 degrees approximately. So this tangent line is going to make 71.57 degree angle, and the negative sign tells us that it is made in the clockwise direction. So this is 71.57 degrees angle. Now if I draw the normal and tangential coordinates, if let's say that the collar reaches here, so let's say that now the collar is at B, so this will be our tangential axis and the normal axis is going to act towards the center of the curvature. Let's say that this is our normal. So if this is that horizontal x-axis with which this angle is made, 71.57 degrees. So this normal is perpendicular with the tangential axis. Let me draw the free body diagram here. This is that collar, and this is that tangent to the path. This is the tangent to the path, and this is the normal. Let's say this is the normal. And this is that x-axis which is horizontal at point B. And this is our tangential axis, this is our normal axis, and this here we have that angle which is 71.57 degrees. And as we can see that if the collar is somewhere here at point B, then the spring force is going to act in this direction. So we will have the spring force in the negative x direction. So I have to show that spring force. So here we will have that spring force which is going to act in this direction, and the weight is going to act vertically downward. This is the weight. And similarly, if the angle between the normal and the tangential axis is 90 degrees, so then this angle is 90 minus this. So 90 minus 71.57, this angle is 18.43. So here we have 18.43 degree angle. And similarly, if we look into this is the angle between the weight and the x-axis is 90 degrees. Since this is vertical, the weight is vertical, so this angle is 90 degrees. So again the weight is making that same angle, this 18.43 degrees here. So this is 18.43 degrees. So now we can resolve the weight and the spring force. This is that spring force. Let me write this as spring force, and this spring force will be equal to KSB. And we know SB is the elongation in the spring when the collar is at B. So we have determined that SB is this OB length, the stretched length minus the unstretched length. So OB is 3 and the unstretched length is 2, so this is 1. So this spring force is K, so K is 10. So 10 into SB, which is 1, so this is 10 pounds. So the spring force is 10 pounds. So we can write that this is 10 pounds. Now if we want to find the normal, so we have to the normal force of the rod. So the normal force of the rod is going to act in the negative n direction, like this. This is the normal force which is applied by the rod on the collar. And similarly, if I extend this normal axis, this is that normal axis, so we can resolve this weight into its components. So the weight will have two components. One of the component of the weight is going to act in this direction, that is in the positive t direction. This one will be the cos component. And similarly, one of the component of the weight is going to act in this direction. So we can place it here. This one will be the sine component. So now if I apply the summation of forces along the normal axis, that will be equal to MAN, and we know that AN is V square divided by the radius of curvature, and since the collar is at B, so this will be V square, and the radius of curvature at B. So now we have to find the radius of curvature at B first before applying this equation. So as we know from previous chapters that the radius of curvature is equal to 1 plus dy by dx square to the power 3 divided by 2 divided by d square y divided by dx square and the absolute value of that. So now we know dy by dx is minus x. Let me write that dy by dx is minus x, and when the color is at B, x is equal to 3, so dy by dx at x is equal to 3 is minus 3. And if we take the second derivative of this, dy by dx is minus x, so if we take the second derivative of this, so d square y by dx square will be equal to minus 1. So now if we put these values in this equation, so we will have dy by dx is minus 3 and d square y by dx value, the absolute value of minus 1 is 1, so we will have 1 here. So this is 1 plus 9 is 10, so 10 to the power 3 divided by 2, so 10 to the power 3 divided by 2, this will give us the radius of the curvature, that is 31.62. So radius of curvature at B is 31.62 feet. So now we can apply this equation. So the normal force is acting in the negative n direction. Or first let me resolve these forces. So this spring force can be resolved into two components again. So we will have one component is going to act in this direction, that is in the positive n direction, like this. So this one is the cos component, so this is 10 cos of this angle, so this is plus 10 cos of 18.43, and then this component of the weight. So this component of the weight is, and the weight is 2 pounds, right? It is given as 2 pounds. This is 2 pounds. So this is 2 sine of this angle 18.43. So we will write plus 2 sine of 18.43 degrees, and this n is acting in the negative n direction, so we will write minus n, and this is equal to, the mass is 2 divided by g value, is 2 pound weight divided by g value, which is 32.2. Vb is known, 34.06 square divided by the radius of curvature at B, which is 31.62. So we can find this is 10 cos of 18.43 plus 2 sine of 18.43. This gives us 10.12. From this we get 10.12 minus n. This is equal to this thing. This is 2 multiplied by 34.06 square divided by 32.2 multiplied by 31.62. This gives us 2.278, which is approximately 2.28. And if I bring this n to the other side of the equation and this to this side, so this n is 10.12 minus 2.28. So 10.12 minus 2.28, this gives us 7.84. So n is 7.84 pound. So this much force is applied by the rod on the collar when it is at B. Now similarly, if we apply the summation of forces along the tangential direction equals to the summation of forces along the tangential direction, this will be equal to MAT. So in the tangential direction, we have this cos component of the weight, which is 2 cos of 18.43. This is acting in the positive t direction. Similarly, this f of s will have one component which is going to act in this direction like this. So it is acting in the negative tangential direction, so you will write minus, and this will be the sine component. So this is 10 sine of 18.43, and this will be equal to the mass. So mass is again weight divided by g value, which is 32.2, into the tangential acceleration. So this is the left hand side of the equation is 2 cos of 18.43 minus 10 sine of 18.43. This gives us minus 1.26 minus 1.26 1.264, and if we multiply it by 32.2 divided by 2, this will give us the tangential acceleration. So this answer multiplied by 32.2 divided by 2, this gives us minus 20.35. So the tangential acceleration is minus 20.35 feet per second square. So this is the decrease in the velocity magnitude when the color is traveling from A to B. So this is the solution of this particular problem. I hope this will help you in your learning. Do subscribe Engineers Academy if it helps in your learning.